Hi everyone, in this short video I will briefly walk you through how to use the SUMIFS function in Excel to create an H-class distribution by stand group or species graph. So what you see here is the data file pulled from Patchworks that contains all our information from our forest planning model. And you can see that there are many columns with lots of information, but because we are hoping to create an H-class distribution, we only need a few of those. So first of all, we need to know the age in our modeling year 0. And in this case, our age is shown in column E. I will mark this column with a specific color so I get an overview over the data that I'm going to use. Then additionally, we want to look for specific stand groups. This information can be found in column F. So we mark that as well. Finally, we need the area in hectare. And this information we can find in our column G in this case. It may be that in your data file the columns are sorted a bit differently, or if you use a different data set altogether, there may be additional columns that you cannot see in this example, or some columns may be missing, but you will definitely always be able to find the information that I've just highlighted. All right, now we want to get an overview over what we have, and we can do so by actually giving us the possibility to filter the data that we have in these columns. Because if you try and scroll down here, you'll see that there are thousands of rows, and going over these rows by hand, if you like, is obviously too much. Okay, so let's click on the Data tab on the top here in Excel and push the Filter button, and you'll see that next to the header, a little arrow appears. And if you push that arrow, you'll get a drop-down list that allows you to see all the ages that are present in this specific column. So you see that the oldest age actually in this case is 262 years at modeling year 0. Let's have a look at the next column, our stand groups, and filter those as well by adding the filter here. Now if we push the little arrow that appears next to our column header, we see that actually there are 3 stand groups, 1, 2, 3 that are currently in use, and then we have our 3 900 level stand groups. And maybe you recall that the 900 series stand groups are non-timber harvest land base. And this information you can find in the stand group definition spreadsheet, which is in the folder titled 00 documentation in the model directory, but we've also uploaded it to Canvas for you. Okay, so let's see what the approximate area size of each of our polygons is. Again, we use our filter tool and just push on the little arrow and see, wow, there's quite a range. So our largest polygons are over 2 hectares in size, and our smallest are actually, just a tenth of a hectare. Okay, now we want to maybe apply those filters to all 3 columns. What we do to do that is mark all 3 columns and push on the filter button again until we get our little arrows in all 3 columns. And that would allow us, for example, to filter by 2 criteria. So for example, I could now say I only want to see all those polygons that are 10 years or younger, and those should all be in stand group number 1. So then the software would actually filter for you, and you would only see those entries that actually meet those criteria. However, we really want to look at everything that we have, because our plan is to develop a H-class distribution, and we can use some of the available functions in Excel to allow us filtering the data in a more comfortable way. So the first thing we do to get a bit of a better overview is we hide, we don't get rid of things, but we hide everything that currently we don't need. And I'll simply mark the last line after the columns that I'll actually need for this exercise, and then scroll to the right using this bar on the bottom here until I reach the final column with information in it. I push Shift, hold it down, and mark this final column with a left click. Then I right click into the marked area and choose from this drop-down menu here hide. And what this does is actually hiding all the columns that you had just marked. And you see that now actually the column labeling jumps from G to CW, and your columns that you just had marked are hidden between these two. If you want to show them again, what you do is you mark the tool that you still see, and you right click into the area that is now marked and choose unhide, and surprise, your columns are all back again. Okay, so let's get rid of these or hide them, and think about what we have to do next. So we actually want to create an age class distribution. What that means is that first we have to start thinking about what our age class ranges are that we want to display. So let's assume we want to use 10-year age classes. That means my first age class might actually contain all the years between year 0 and year 9. What we can do to simplify the development of our age classes here in these two columns is to just go into the row underneath our first timeline, or range if you like. So let's call this from 2, and then go in the row underneath and say, okay, I want to use the minimum age plus 10 years on the left hand of the equation if you like, and the maximum age plus 10 years on the right hand. And you'll see that this way we get to what we want to have in a very simple fashion. Now we pull this down, and the question is, how many age classes do we actually have to show? And maybe you remember that I earlier used this filter function to see what the highest age was that we find in our data, and it's 262. So if we stop at 270 to 279, we will definitely be able to capture our highest age class. Okay, so now the SUMIFS function comes into play. And basically the SUMIFS function allows us to sum cells in a range using multiple criteria. So we will sum values to which multiple criteria apply. The way we use this function is we just click into the cell in which we want to use the function, and we start writing it. So SUMIFS, and you see that actually Excel already offers me this function here, and I double click it, and then it shows me what's happening next. So first of all, it wants us to tell it what the sum range will actually be. And the sum range is the range that I actually want to sum up. So in this case, our area. So I mark our entire column containing area, but because pulling it down like I've just shown is going to be super tedious, I simply click on the very top, and you see what the software does. It says GG, so it'll take into consideration the entire column. So this is the sum range, the range I want to sum up. Now I type in a comma, and the next information that's being asked from me is the criteria range. So this is the criteria to use on range 1. And the criterion we want to use is, first of all, age, because we are now in this first step of our age class distribution looking to sum up all the polygons that are between 0 and 9 years in age. So again, we mark the entire column with age information, which in this case is column E. We type in a comma, and now we will have to give it a criterion. And the criterion in this case will be, because we're looking at everything between 0 and 9 years in age, please sum up all the cells that are smaller or equal to 9. So pushing the return button already gives us a reply or a response, and you see that I quickly format these cells so later the information is going to be a bit easier to read. So we have in our entire data set 654 hectares of stands that are between 0 and 9 years of age. Now we can pull this down, and Excel will automatically put this formula into the cell below and make adjustments, like for example pulling down this cell with it so the relations are all or remain all intact. However, now we need to add a criterion because we cannot only go by smaller or equal to 19, because if we would not include this left-hand limitation, the software would actually sum up all the stands that are younger than 19 years, which would include those that belong to our first age class. The way we do it is we simply type in another comma into our equation, and what the equation will allow us to do is to choose a second criterion plus a second range, which all cells that will be summed up in this cell will then have to fulfill. Okay, so we actually want to look at age once again. And now, as I said, we don't only want to include those polygons that are smaller or equal to 19 years of age, but we also want to exclude everything that is younger than 10. So the next criterion to add would be that our cells to be added up have to be larger or equal to 10. We push the return button and we get our result, which is that in our entire dataset, we will find 674.3 hectares of stands that are between 10 and 19 years of age. You may have been wondering what this AND symbol here is in our function, and in Excel this is the concatenate operator, which joins two strings together and returns a string. In cases like this, the operators must be embedded within double quotes or the string evaluation will fail. Okay, so in my last step, I basically just pull down this equation and I get the area for each of our age classes in hectare. So the next thing that I want to do is I want to create a column like this for all my stand groups of interest. Currently, my stand groups of interest may be stand group 1, 2, and 3, and they are characterized in this table by this number. So I know whether or not a polygon belongs to stand group 1 if it has in this column a 1. So I write into my header 1, 2, and 3, or whatever number your stand groups might have, or whatever characteristic you want to group by. Then I pull over my equation from my initial attempt at calculating area per age class. And now I have to make sure that everything is still in place, because by pulling an equation from one column to another, the relations move with it. So I have to basically move my criteria back into place. After bringing everything back into place, I want to add a new criterion. I do so by going into my equation, typing in a comma, and just like before, I'm given the opportunity to select a third criteria range. This time it's all about the number of the stand group. So I choose the column that contains this information, in my case column F. I push the F4 button so it's fixed. Should I pull it to the right later for my stand groups 2 and 3, I push or type in another comma and select the criterion that I actually want the software to take into consideration when summing up polygons for this specific column. And this criterion is that these polygons have to belong to stand group number 1. I push the return button and everything is in place, and I immediately see that there are 0 hectares of polygons belonging to stand group 1 that are currently aged 0 to 9 years. Now for my second age class, I have to pull over the equation from my overall calculation again as well, because I added this extra criterion earlier and I don't want to do all the work again. So I pull it over, I make sure that everything is in place. I can fix my columns with my F4 button if I like, and I definitely have to do one thing, and that is once again add a second criterion, which is the stand group and the fact that I only want to take stand group 1 into consideration in this case. Okay, so everything is in place if your equation looks something like this. Now the next thing we can do is just pull it down like before and populate our entire H-class distribution. If you click on a random cell in this new column, you'll be able to double check whether or not the relations actually are all still intact. Take the time to go through the equation once or twice to really make sure that everything is in place before you tackle column for our second H class. Now it should be relatively simple because you've fixed everything with your dollar signs, and technically you should be able to mark the entire column and just pull it over twice. Let's do that and just click into a random cell to double check things. So I see from the markings around the cells that show me the relations here that everything is still fine for our stand group 2. And let's see what's going on in our third stand group. Yes, things look quite well here too. Perfect. All right. So we are already there to start drawing our graphs. The only thing that is still missing is that we actually label our H classes, and we do so by just typing the labels into the first column that we may still have available in front of our entire table. And if you don't have a column available, just create one by right-clicking in here and saying Insert. Okay, now we are ready to create our graph, and we do so by marking the chart area. And the chart area in this case are all the columns containing information about area per stand group. Then we go to Insert and choose Bar Graphs. And you see the second option here are stacked bars, and we can click that. And here we go. We already have our basic graph showing us H-class distribution per stand group. There are a couple of things that you can do to make your chart look even nicer or to optimize whatever you want to show. And one of these things is to adjust the legend. You see that currently the legend just says Series 1, Series 2, and Series 3. But from our documentation stand group definitions, we know what our stand groups actually are. So we can, for example, say insert a row, and we want to shift the cells down, so we have a row above our header, and we can say, okay, stand group 1 I remember was fir, then stand group 2 was pine, and stand group 3 was deciduous. Now if we right click into the chart, we can choose select data. And for each series, we can edit the title by basically just giving the series name that we've just typed in here. And I'll just do so for our 3 stand groups quickly. And you see that the legend is automatically changed to include this new column header. Now if you change the header manually, it'll automatically change whatever information is available in your chart here. Additionally, we may want to include our axis information for the x-axis, which contains the information for which H class we're actually looking at. And you see that it automatically numbered our columns from 1 to 28 here. And actually, we don't have to do anything here because this number corresponds well with the H class that we would have manually assigned anyways. So we can leave it as it is and just say OK. But something is still missing to make this a good chart, and that is actually a legend for each of the axes. We can put in chart elements by clicking on Design and then Add Chart Element, and you see that we can add axis title for both the primary horizontal axis as well as the primary vertical axis. So just click that, and then we can just type in area in hectare for our y-axis and H class for our x-axis. Now you may feel that you cannot yet see well what the graph is actually showing. You could pull the legend up into the graph, for example, so you can increase the size of what is actually shown. But even more efficient is to change the width of your bars. And you can do so by formatting your data series and actually decreasing the gap width between your individual bars. So let's see what that looks like if we reduce that to 50, and you can see that your bars already become quite a bit thicker if you like. Additionally, if you feel inclined to do so, you can, for example, get rid of the decimals in your on your axis, and you do so under axis options number here and just set decimal places to 0. And last but not least, obviously you can play around with the colors that your graph is displaying until you find something that you think really allows the reader to easily see what your graph is showing. So you don't want the colors to be too similar and you don't want them to be too soft, etc. However, I recommend that once you chose one color for a stand group, you actually stick to that color, or maybe even use the colors that can be seen on your map in your modeling software. All right, so that's all for tonight. I hope this helps you with your area description, and I'm very much looking forward to seeing what you will be doing with this. And I wish you a good weekend.